Welcome to AI Research Weekly, the show that cuts through the noise to bring you the most impactful technical developments in artificial intelligence. I'm Nova.
And I'm Onyx. This week, we're diving deep into the burgeoning field of agentic AI. It's clear from the latest reports that the research community is grappling with the complexities of autonomous multi-agent systems, particularly around their reliability, governance, and ethical implications. We've seen a surge in papers pushing the boundaries of what these systems can do, while simultaneously highlighting critical gaps in their robust and responsible deployment.
That's right, Onyx. Our intelligence report shows over 500 new papers ingested this week, with a striking number of novel concepts emerging in agentic AI. But a sobering statistic stood out. Over 83% of AI research still neglects trustworthiness and mission assurance. That's a huge delta between innovation and responsible scaling, wouldn't you say?
Absolutely, Nova. It underscores the urgent need for foundational work in reliability engineering for AI, similar to what we see in safety-critical systems. Let's start with a crucial architectural advancement addressing this head-on, the Improving Google A2A Protocol paper.
This one immediately caught my eye. The paper tackles a very real and pressing problem. How do you prevent sensitive data leakage and unintended harms in complex multi-agent systems? They highlight critical limitations in Google's existing A2A protocol, especially with things like payment credentials and identity documents.
Their key contribution is a proposed modular, interceptor-based architecture, specifically a zero-trust interceptor. It's designed to enforce explicit consent orchestration, introduce ephemeral scope tokens, and route sensitive data through direct user-to-service channels, bypassing agents entirely when necessary. This is a significant shift from relying on agent-level safeguards to a protocol-level, deterministic approach.
The ephemeral scoped tokens concept is particularly interesting there. It's about tokens with limited lifetimes and restricted access, precisely engineered to minimize sensitive data exposure. It's a very practical security primitive for these increasingly interconnected agent ecosystems.
And the results are compelling. They conducted component-level evaluations across 5,000 protocol enforcement trials. Their enhanced protocol structurally eliminated sensitive data leakage paths, achieving a 0% structural success rate for leakage under their stated enforcement assumptions. Plus, it maintains sub-millisecond overhead, which is crucial for real-time agent interactions.
A 0% structural success rate for leakage is a big deal. But I have to ask, how much does this depend on the stated enforcement assumptions? Are we pushing the problem down to the integrity of the interceptor itself, or are there inherent architectural guarantees? What happens if an agent is compromised before it hits the interceptor?
That's a fair challenge, Nova. The paper focuses on protocol-level enforcement between agents and services, assuming the interceptor itself remains uncompromised. It's about securing the communication and execution pathways. It's a layer of defense, not a panacea for all forms of agent compromise. This kind of architectural hardening is vital, especially when you think about the concept of audit-stable meaning that we saw in another paper this week. Ensuring past decisions are verifiable under the exact semantics in force at decision time becomes incredibly difficult if the underlying protocols are leaky or mutable.
Right. And speaking of foundational issues for multi-agent systems, the paper Entropy, Topology, and the Execution Boundary offers a really fascinating perspective on their reliability. It really hones in on the systematically undergoverned execution boundary between an LLM's language generation and an irreversible physical action.
This paper dives into several critical aspects: silent entropy accumulation in LLM agent lifecycles, the interaction of communication topology and memory depth, and how these factors determine whether distributed consensus or fragmentation emerges. It's a powerful conceptual framework for understanding the systemic vulnerabilities of agentic AI.
The most striking finding for me was how governance layers, inserted specifically at that execution boundary, could dramatically reduce unsafe action rates. They reported a reduction from 88% to near zero without needing to modify the underlying LLM generator. That's a huge implication for practical deployment. suggesting we can build safer systems with better external controls rather than solely relying on ever more perfect base models.
Exactly. It reinforces the idea that reliability isn't just about the model's internal reasoning, but the entire socio-technical system surrounding it. They're finding that deliberative consensus in multi-agent oracle systems can degrade accuracy below single-model baselines when confidently wrong agents influence correct ones is also a crucial caution for anyone building multi-agent systems for critical tasks. More agents don't always mean better outcomes if the communication and arbitration aren't robust.
That's a profound insight. It challenges the assumption that multi-agent systems automatically lead to improved decision-making through collective intelligence. It suggests a strong need for refined communication protocols and possibly dynamic trust mechanisms between agents. It reminds me of human group dynamics, where a confident but incorrect voice can sway the group.
Indeed, it moves beyond purely algorithmic improvements to system-theoretic considerations, using concepts like silent entropy to characterize the inherent instability in agent life cycles. This echoes the broader trend of adaptive governance we're seeing, where frameworks themselves need to evolve at the pace of AI threats.
Let's pivot to a different but equally critical aspect of responsible AI: fairness in agentic systems. The Agent Fair Bench, Do LLM Agents Discriminate When They Act paper introduces a new benchmark that could be really impactful.
This is a crucial addition to the evaluation landscape, Nova. Agent Fairbench provides a cheap, reproducible, and multi-domain benchmark for assessing demographic disparity in LLM agent actions across scenarios like hiring, lending, and medical triage. They're specifically looking at how increased agency, like chain of thought, multi-agent deliberation, or tool use, might amplify existing biases, a proposition from the bias conduction framework.
That's the P3 or superadditivity proposition, right? That's really important because a lot of the initial thinking was that more complex reasoning might wash out simple demographic biases. Agent Fairbench directly tests that. What makes their methodology stand out?
Their core methodological innovation is the arity-matched null approach. A pilot study revealed that simply comparing a 6-group score spread against a 2-run noise difference could overstate disparity by about 2.4x. This new methodology aims to prevent that overstatement by carefully controlling for statistical artifacts when assessing demographic effects. They use synthetic, demographic-neutral profiles, following the Bertrand-Melanothan tradition, varying only a name-coded race-gender signal in counterfactual matched sets.
So they're ensuring that any observed disparity is more likely attributable to the agent's behavior and not an artifact of the measurement technique itself. That's a significant improvement for benchmark rigor. What were the initial findings?
In their pilot study using Claude Haiku 4.5 and this arity-matched null methodology, they found no demographic effect above sampling noise. 0 out of 120 pairwise and 0 out of 9 omnibus contrasts survived correction. This is an interesting initial finding, but crucially, they also confirmed that the benchmark instrument can detect planted bias when it's present, demonstrating its sensitivity.
That's good news, at least for that specific model and pilot scale. But the key is the methodology itself and its ability to robustly test these BCF propositions across various models and agency levels. As agents become more sophisticated, this benchmark will be vital for guiding ethical development. It highlights the need to move beyond simple fairness metrics and consider the action-level outcomes of agent decisions.
Absolutely. The benchmark includes 4 agent scaffolds of increasing agency, which is key to empirically testing whether greater agency leads to increased or decreased disparity amplification. It's a step toward more holistic evaluations of ethical AI in action.
Moving from ethical considerations to fundamental capabilities, the paper Evaluating Long Horizon Reasoning and Self-Correction in Large Language Models with Verifiable Task Chains addresses another crucial area for agentic systems: their ability to handle multi-step, complex problems.
This is another excellent contribution to the benchmarking space. The authors introduce a new benchmark based on programmatically verifiable Python task chains. This directly addresses the limitations of single-turn task evaluations, giving us a much clearer picture of how LLMs perform on tasks requiring iterative workflows, planning, and self-correction over an extended sequence of actions.
They evaluated 10 state-of-the-art models, including GPT-5 and Gemini 2.5 Pro. What were the key takeaways on performance?
Unsurprisingly, GPT-5 achieved the deepest task chains and the highest error recovery rate among the tested models. This highlights its continued lead in complex reasoning tasks. However, the study also found that sequential reasoning depth and error recovery are only partially correlated. Some smaller models, while not reaching the deepest reasoning chains, demonstrated surprisingly strong error recovery capabilities.
That's an interesting nuance. It suggests that models might specialize or have different inherent strengths when it comes to self-correction versus pure reasoning depth. For practical agentic systems, strong error recovery might be as critical as deep reasoning, if not more so, especially in environments where unexpected conditions are common.
The paper identifies contextual consistency and error recovery as critical objectives for future LLM development. It underscores that we need to look beyond raw accuracy on individual steps and consider how well models can maintain coherence and adapt across an entire multi-stage task. This kind of evaluation is indispensable for building truly robust autonomous agents.
So for our listeners developing agent architectures, this means carefully considering how they design their agents to leverage these error recovery capabilities, perhaps with explicit replanning or reflection steps, rather than just chaining together calls to a powerful but potentially brittle base model.
Precisely. The benchmark provides a reproducible methodology for understanding these capabilities and pushing them forward. Industry Watch. Now let's turn to our Industry Watch segment. This week, the overriding theme is the accelerating shift in how AI is transforming the professional landscape, particularly for software developers.
Yeah, I saw that paper. From coder to orchestrator, how artificial intelligence is transforming the role of software developers. It's a survey from May 2026, so very recent, and it revealed that 92% of computing students and early career professionals regularly use AI tools. And get this, 46% reported over 75% of their code is AI assisted. That's a massive shift in a very short time.
It truly is. The paper argues that the profession is moving from direct code authorship to an orchestrator role, managing and integrating AI-generated code and agentic workflows. Critically, the top-cited skill gaps among surveyed professionals are multi-agent orchestration and prompt engineering. This highlights a disconnect between current education and rapidly evolving industry demands.
That connects directly back to what we were discussing about multi-agent systems and their reliability. If developers are becoming orchestrators, they need to deeply understand concepts like ephemeral scope tokens, execution boundaries, and how to rigorously evaluate agent fairness. It's not just about writing a good prompt anymore, it's about designing and governing complex AI systems.
Exactly. The paper even proposes an AI orchestrator developer competency model to bridge this curriculum industry gap, emphasizing systems thinking, prompt engineering, agent governance, and ethical oversight. This isn't just a theoretical shift, it's driving concrete changes in what skills are needed on the ground.
And the fact that only 19% of respondents had equitable access to professional AI platforms is a worrying signal. If access to these advanced tools is limited, it creates a potential barrier to developing these critical new skills, exacerbating the talent gap.
That's a valid concern, Nova. The industry is rapidly adopting these tools, but the infrastructure and training aren't keeping pace for everyone. We're seeing models like GPT-5 and Gemini 2.5 Pro pushing the boundaries of what's possible, but leveraging them responsibly requires a new kind of expertise that's still being defined.
This whole discussion reinforces the overarching theme from our intelligence report. While technical progress in AI is accelerating, the holistic, responsible deployment is lagging. We're building incredibly powerful agentic systems, but the architectural security, governance, and ethical evaluation frameworks are still catching up.
Precisely. The industry is quickly finding that while agents can automate and accelerate, They also introduce novel failure modes and governance challenges. The research we've discussed today, from hardening protocols with ephemeral tokens to building better benchmarks for long-horizon reasoning and fairness, is directly responding to these emerging industrial needs.
It feels like the industry is now acutely feeling the pains that researchers have been predicting for a while. The move to agent-driven paradigms isn't just about efficiency, it's about a complete rethink of software engineering and system design.
And the demand for these new skills will only intensify. Developers who can effectively orchestrate, govern, and secure multi-agent systems will be at a premium. Conclusion.
So, looking ahead, it's clear the conversation around agentic AI is shifting. It's no longer just about building agents that can perform complex tasks, but building them to be robust, secure, and fair.
That's right, Nova. The focus on architectural solutions like ephemeral scope tokens, the emphasis on system-level reliability at the execution boundary, and the introduction of nuanced benchmarks like agent fair bench and verifiable task chains for long-horizon reasoning all point to a maturing field. We're moving beyond capability demonstrations to addressing the hard engineering and ethical problems of deploying these systems in the real world.
I'm particularly interested to see how adaptive governance frameworks will evolve in response to the rapid pace of AI-driven threats. The theoretical groundwork is there, but translating that into practical, deployable systems is the next big challenge.
And the industry will be watching closely, as the shift from coder to orchestrator necessitates a completely new skill set. We'll need to see education and training catch up to these advancements to truly realize the potential of agentic AI responsibly.
A lot to keep an eye on. That's all the time we have for this week's AI Research Weekly. Join us next week as we continue to track the cutting edge of AI innovation.
Thank you for listening.
Goodbye.